This conference will now be recorded.
Yeah, hi guys. Myself Ravinder. I'm working as a SQL DB last 16 years now, and MongoDB working close to 9 years now, and working on Azure SQL and AWS also. I do work on Postgres as well along with this. So this is my technical background. A little introduction about myself. So today's agenda, we will talk about NoSQL and RDBMS comparison. Why NoSQL is growing in the market? What are the reasons NoSQL is needed in the market? When we have RDBMS since very long, RDBMS is started in 1962. Oracle started in 1962, way ago, and it is so sophisticated. Not only Oracle, we have SQL Server, Postgres, Greenplum, MySQL. There are many RDBMS products which are very sophisticated. Why we need to have NoSQL as an alternate solution? What are the use cases we are getting fulfilled using the NoSQL technologies? You get to know all these points by the end of the today's demo. After today's demo, you understand what is a need the NoSQL in the market. In fact, what are the business use cases NoSQL only can fulfill, not RDBMS. You get to know all this point by point. Okay. Fine. So NoSQL is actually not a new technology. It is introduced quite a long ago, 1998. If you talk about roughly 26 years ago, it started, but it got the market last 15 years, in fact. So it is introduced by the person called Carl Stroji in 1998, and it used to be called as file-based database. So all NoSQL technologies follows a similar architecture like RDBMS in terms of data handling, how it happens in the background, almost similar. NoSQL products that I'm talking about, and these products are not new in the market, but the market is gaining too good market towards NoSQL. The reason behind is, if you talk about last 15 years, the evolution of IT devices have increased like tenfold, hundred folds. Like what I mean exactly, everybody have a smart device now in their hand. We have a like a phone. It's like a mini computer. It can do anything. You can install n number of apps. You generate different types of data, versatile data, type of data. Like some are structured, some are unstructured, some are semi-structured. You don't know what is the structure defined in the background, but you're interacting with the apps, you're doing the data loads and sending the messages, receiving the messages, doing your own management. But in the backend, things are getting managed. So all Play Store apps, whatever you're using nowadays, are deployed on the NoSQL technology only, not on the RDBMS. The reason being is our data is actually not compatible with RDBMS, because we upload the data in a different format. Some can be structured, some can be unstructured, and some can be unstructured and semi-structured. So what exactly structured, semi-structured, unstructured, I'm going to explain. We're going to see that data feed in the live. Today itself, I'll show a few examples so you understand. But understand that NoSQL can only take the data in any format. You cannot load the data in the RDBMS systems the way you want it. If just for the example, I have a SQL server, I have a database here, a class, and I have a table called student2. And if you see, there are three columns: S number, S name, S address. If I wanted to load the data into this table for any reason, I have to follow the structure what is already defined. So if I wanted to insert into student values, just for the understanding sake, I wanted to show this. So if I'm trying to load the data here, okay, so address. If I am fitting the data into the defined structure, it will accept the data. Okay, it is accepting the data. You can see that extra record I just loaded, it is added to the table. But if I add one more field extra, this is not defined. So when it is not defined, you cannot load the data. It says that column name, number of supplied values does not match the definition. You have to introduce this field to load the data first. That is called RDBMS, called structured data model. You define the structure, you load the data within that structure. You cannot violate the structure. That happens in the RDBMS. If you talk about NoSQL, this is a NoSQL MongoDB. Don't worry how did I install, how I started, all that. Just see the data, how it is accepting it. So I'm going to use a database called cloud. I don't have a database cloud here. Just I'm using it. Once you use it, it will create the database automatically. You don't have to create a database. Everything is dynamic. It happens on the fly. You don't define anything in the MongoDB or any NoSQL basically. These are all schema-less products. You don't have to define the schema. Schema will create it on the fly, in fact. Now, if I go and create a collection, db.create collection. Example, I'm creating a collection called student. It's equivalent to table here. Okay, we created a collection called student. Now, if I go and read the student, we don't have anything. I'm reading the collection. It is empty as of now. So I'm going to load the data, inserting the data. Don't worry about the syntax. Understand how it is accepting the data. Example S number one. Next, in the next record, S number two, S name, Avamshi. Uh, that's it. Next record, I'll go with the third record, and here and address. I'll tell you what I'm trying to do here. Next record, one more record I'll enter and I'll show the data. Fourth record, and here I'm going to add phone number. So if you observe carefully how we are loading the data, db.student. This is one example, it's one of the biggest advantage the NoSQL has, in fact, right now. If you see, the first record have only one field, second record has a two field, third record has a three field, fourth record has a fourth field. Every record has its own shape. There is no definition of the fields you have done. It is accepting the field automatically. It is adding the field automatically. Everything is automatic. It does not reject any data. You load the data in any format, it accepts the data in that format. And it builds the field set automatically. It will accept the data, how you are assigning the data. It doesn't matter. It does not reject any data in any format. This is called unstructured data. Basically, you're not making it structured. You're defining it the way you want it. The backend is accepting the way it is coming into the system. It is not rejecting it. This is called unstructured data model, in fact. The RDBMS cannot do it. RDBMS cannot do the, like the data, whatever the way it comes. You have to define the structure first and then load the data within that structure. So RDBMS products absolutely cannot serve the purpose of unstructured data. Okay, so this is a one big difference you see between the NoSQL and RDBMS systems. There are many, we're going to discuss, but this is one of the important, differences that you need to take into notice. In fact, right. So this is one good example. If you talk about architectures, how RDBMS function, how NoSQL function, then I'll come to the slides slowly. Just try to follow. I mean, these discussions will correlate our all points that I'm going to discuss in the slides. If it is RDBMS, what do? You stand up a machine. Inside it, you'll have a data drives. Okay. If your data is growing, you'll add up more drives, more data drives, and then you'll have one log drive, assume it is. If a data is growing, what do? You extend the drives to accommodate the data and each file. You created a file and file groups. Within the file group, you are adding more files, and each file is growing bigger. You keep extending the drives to accommodate the data. As your data is growing, you definitely have to add more CPUs, more number of cores to deal with the amount of data that is growing on the machine. At the same time, you have to add more RAM also. So your resources, you are adding it to one machine only. All your resources are growing vertically in a single machine. Okay, good enough. RDBMS is capable of processing any amount of data. That's okay from the product point of view, as you're giving more the more CPU cores as the data is growing to accommodate the processing power. But when the data grows like 10 TB plus, single database growing up to 10 TB, what happens? We cannot do the rebuild indexes over a weekend. 10 TB database is itself, you need a 10, the biggest table, three times of that table log file must be given. And also, you cannot do the 10 TB database rebuild index over a weekend. We have such databases in our environment, 10 TB databases in our environment in SQL, we have targeted tables by table. Like we cannot rebuild the entire 10 TB over a weekend. And they have a 12 hours window on the Saturday itself. Sunday, again, they'll do the different business related jobs, in fact. 12 hours window is not sufficient to do the rebuild for the 10 TB, in fact. So that's why we created multiple schedules. In each week, we target different tables. Within a like 4 or 5 weeks in a month, we target almost all bigger tables so that we will sustain with the performance. If you cannot, if your database is growing and growing further 20 TB, as you may guess, you cannot do the rebuild at all. If you cannot do the rebuild properly on all tables which are large, data will go through the scan to get the data. When it is scanning, it will definitely slow down your performance and it will kill the resources also. So RDBMS is so sophisticated. It has many features which market is still using. It is definitely needed. It doesn't have end of life, of course, but the problem here is choking of system with all your data in a single system is not possible to manage 20 TB data in a single system in RDBMS, because you cannot do the maintenances over a time, and down the line you see the bad performance because indexes are not intact. In fact, that will be problematic, right? If it is a NoSQL, the architecture is different. So how it handles the data? So let me draw the this thing, all the components, then I'll explain you. So just try to understand. I mean, these concepts we will see in practical, how data distribution will happen, how the scaling will happen, how the availability of the data will be more, and the NoSQL than RDBMS, how it is good compared to RDBMS and many features. Okay, significant features. So let me just quickly draw this and then I'll explain you the connectivity here. This is called sharding in NoSQL technologies, or any technology you talk about. This is what it follows in the NoSQL. Here we in the MongoDB we will call it sharding architecture. This is called application. This is called mongoose or router servers. This is called config servers. These are all called shards, replica or shards. You can say that shard one, and this is shard two. I'll explain. Just give me a minute. I'll just give the names and explain the connectivity. Shard three, something like this. So here applications will hit the mongoose or router, you can say that, and they'll have multiple routers to have the availability of the applications. If one router is down, they can use other router to talk to the cluster. Okay. So Mongoose will go to the config server. Config server will maintain all the shards information, all the shards, which how many shards are there, which shard is active, which shard is down at the moment, where to push the data, how to balance the data. Entire mechanism will happen in the config servers. It maintains the metadata of your entire cluster, entire metadata. So example, I have assume a case 100 GB collection. 100 GB collection, I wanted to distribute to each shard automatically. 33 GB here, 33 GB here, 33 GB here, roughly 100 GB. Okay. So when we are loading the data itself, data is writing into three different servers, and each server will have its own availability, replica set. So if one of the node goes down here, other node will come up with a primary role and it will act like a primary. It gives the response to the applications. You don't see the downtime here, in fact. So sharding is a collection, I mean, table level technology. Anyway, I'm going to discuss in detail in practical when we start the product. But what I wanted to convey is there is no restriction on the amount of data that you can grow in the Mongo cluster. If your data is becoming 10 TB here, assume a case, 10 TB, 3.3 TB here, 3.3 TB, 3.3 TB here. 3.3 B is more if you feel like for a single replica, you keep add one more replica here. So 3.3 TB will become 2.5 TB, 2.5 TB, 2.5 automatically. You don't have to do anything. One single command can add the one more replica, and whatever the data you see more here, it will distribute the load to this empty node automatically. It balances all the nodes automatically. You don't have to worry about. 10 TB become 2.5 to be 2.5 to be 2.5 2.5 automatically. If data growing again, you keep add one more shard, again data distribution will happen and then it will scale automatically. So whatever you are writing in the Mongoose, it is going to 5 different servers parallelly, and you are also reading from 5 different servers. So this is called horizontal computing model. We call it as horizontal. Why? Because data is getting processed, written on multiple servers at one go. Multiple servers at one go. That's why we call it as horizontal computing model. All NoSQL architectures are horizontal computing model. This will follow to scale with any amount of data. We are not flooding one system here. We are flooding a lot of servers. If you talk about Facebook, Twitter, Instagram, you never see it is going down. Why it will not go down? Why it will not have a locking mechanism? Everything will have a consistency. When you want to have the consistency, there will be locking, right? How it will handle? We have the discussion in the architectures. I'm going to discuss in the Mongo architectures. There I'll explain how the social media platforms are running without a downtime. Absolute downtime, absolutely no page timeouts. You never see the page timeouts in the social media platform. How they are actually handling such huge load, like across the globe, people are accessing it, billions of people are accessing, billions of requests processing by second. So how these things are happening? Because your requests are not served by single server. There are hundreds of servers serving your request to get your data out. So there is no load on the one system. Okay, they can process any amount of data with the help of distributed computer model or horizontal computing model. We call it this one also distributed computing model, because you're distributing the workload across the multiple servers at any given point to get the performance. Distributed computing model. Either you say horizontal computing model, distributed computing model, these words indicate the same almost. When it comes to the RDBM systems, you can have other machines. This is like a standby. You can protect the data using the always on clustering, whatever it is. You are protecting the data, not giving the scalability here. We are not giving the scalability. Sorry, don't mind, I got cold. So here you are writing data. You can redirect your read operations to secondary automatically. You can distribute the workload. Only read operations can be distributed. Write operations always will go to the primary only at any given point. If it is a Oracle, what happens? In Oracle, there is a one good concept, a rack concept, where you can write into multiple servers, which is okay, but one physical volume, all will go to one volume only. You are writing into multiple servers, logically showing on all multiple nodes, but at the end you are writing into one place. You're choking the IO at the end when you're dealing with the huge data. So at any given point in the RDBMS, we cannot write into multiple servers, multiple different storages. It's not possible in any RDBMS system. But in the NoSQL technology, we can distribute our write load, read load to all different servers, and each set having a different data. So I have a 10 TB, 2.5, 2 TB, 2 TB, 2 TB, 2 TB, total 5 shards, right? 2 TB in each shard is distributed already. If one of the shard is down, for some reason one of the shard is down entirely, okay, then you have 8 TB data. If one shard is down, doesn't mean that you are losing all the data. You will have 8 TB data still operational online. As long as you are not dependent on this shard, you can operate your business with 8 TB data available. It does not go down in the shard. If one of the shard is down, either shard is still operational with available data. If I write the new data, it will write into available shards automatically. Whatever the data is extra written here, when this comes online, it will distribute to that shard automatically, because this shard went down and a lot of data is written. Data has grown here. Once this shard comes online, it will sync the data to that shard automatically to keep the data equally on all nodes. Automatic. You don't have to do anything. Just configure and leave it. MongoDB configurations are dead simple. Only the thing is understand the architecture, support the technology. That is where the more expertise things will come into picture. Configurations are very simple in the Mongo. You don't have to do too much of effort to configure this big architecture. It is so simple anyway. We will do end-to-end configuration. We will load the data. We will see the data, how the data is getting migrated, how distribution is going on. Everything we can see live. I have a, I'm going to configure. I'm going to show everything. But for now, why I'm discussing on the first day itself this kind of architecture to understand the difference between the RDBMS and NoSQL. This is a major point I want to focus here. RDBMS is a vertical scalability. You keep the compute power one machine and loading a lot of data. It is good that it is definitely good for the structured data model, not for the unstructured at all. If data is growing beyond certain sizes, we cannot do the better data management like rebuilding indexes. If we cannot do, data will be definitely scattered, and the index, the pointers will be wrongly pointed, like histograms will be get disturbed. You'll see the fragmentation. The more fragmentation, the more performance hit on the system. That down the line degrades the system performance because you could not maintain it. But here it is 100 TB, 10 TB, how much it doesn't matter because you are adding more machines. You can easily do the rebuild index on a 100 TB database because it's not in a single system. The more data it comes, if it is not, you're not able to do the index, add some more machines and maintain the data well in shape to get the performance. It is possible in the NoSQL architecture, irrespective of the data size. There is no limitation of data that you can handle as long as you keep growing the server count in the background. It will scale automatically. As you grow more data, you keep add more shards. The more parallel computing will happen, the quicker you will see it. This one thing. Someone have a question? Austin, you're on cam. You can unmute. Yeah. Yeah. Any question? Let me know. Go on mute if not, because it will record the sound. Sim, I'm muting you. If you're not able to do it, fine. So just try to today the takeaway is what is a RDBMS can do, what NoSQL can do. That is what you need to ultimately understand by the end of this discussion. So now the cluster model here, the sharding cluster model here, distribute your workload to a lot of parallel servers. As data is growing, you keep add more shards, it will grow automatically, it will scale automatically. You don't see the performance issues here, absolutely. And also, one entire shard is down, your cluster is not down. It is operationally available shards automatically. When it comes to the RDBMS, a small chunk of data is a 10 TB database. 10 TB database, 1 MB of data is corrupted. Your 10 TB database will be down. Okay, roughly 1,000 pages maximum for a database. 1,000 pages, which means 8 KB. 8 KB into 1,000, 8,000, right? 8,000 KB, which means 8 MB only, right? Roughly 8 MB data can be, if 8 MB data is corrupted, 10 TB database will be down in the SQL server. Irrespective of the size, it doesn't matter. Single database, 1,000 pages are corrupted, database will go into suspect mode. It will not be accessible for the write operations, even for the read also. You can read it, making it to emergency mode, the suspect database, that's a different story. But your database is 10 TB database is down because of 8 MB data corruption. You see here 20% of the data is down, corruption or whatsoever, you still operational with the rest of the data. It gives more availability than the RDBMS. It's not a single point of failure. You are losing 20% of the data, still 80% of the data is operational. You can make it online anyway later on, but whatever the transactions are dependent on that range of data will fail because that data is not available for systems. But whatever the data is available, whatever the data it is, the 8 TB data available, that will be functional basically. So these are all big reasons, guys, basically. And also, NoSQL technologies are open source. This configuration available in the community edition also, free edition. Community edition means free edition. We are running 50 TB data. 50 TB data in the community edition without paying single penny. It's a huge data, in fact, 50 TB. We made it to 35 TB. I'll discuss recently we did 35 TB. We used to have 10 years data here. We made 5 years now. So 35 TB data we are running on the community edition. 35 TB means it's not a small thing, in fact. That too, you are not paying anything to the product person. You're only paying for the storage, the compute model, the infrastructure cost only you are paying, not for the product. So this is where the big challenge is coming. If you talk about RDBMS like Oracle SQL, they are charging you like anything. Oracle even far compared to SQL, 5 times the SQL, 5 even 10 times in terms of licensing. Very costly, Oracle. Then SQL also it's not so cheap. In fact, it is a core-based licensing model. You have to pay a lot of money. So big, the big takeaway, big advantage for the market is it's open source. You don't have to pay anything. You absolutely run any amount of data. But you have the enterprise also, which is a paid version where you will get the inbuilt monitoring, inbuilt backup recoveries, encryptions, and auto scale ups, auto upgrades, auto patchings. There are many things are available in the enterprise versions. If it is community edition, everything you have to do manually. Community edition, everything is manual. No tools available in the market to support that community edition because it's free. Enterprise MongoDB will automate everything end to end. You don't have to do anything on the enterprise version because it's a paid version. So anyway, we will see that feature side as going forward. We should not compare community to enterprise within the Mongo. Let's compare between the RDBMS to NoSQL. That's where we're going to focus. NoSQL represents a group of products and various related data concepts for storage and management of large. So NoSQL also have a group of products like you have a MongoDB, you have a Cassandra, you have a Scalaris, CouchDB. There are many databases we do have in the NoSQL also, like RDBMS, Oracle, SQL Server, MySQL, Postgres, Greenplum. There are many products, right? So like that in the NoSQL also we do have many different products developed by different vendors basically. That's why it is called as NoSQL is also a group of products. In fact, what is NoSQL if you have to define not only SQL? You have SQL which is a structured, it is a rigid model. It accepts only the data in the asset properties principles basically. That is called SQL. But NoSQL means not only SQL. Along with SQL, you have another product which is NoSQL, which does not have to go through all the RDBMS principle. You don't have to. It doesn't follow the ACID properties at all. It will follow the base properties that I'll cover in the course. Anyway, differences between the RDBMS architecture data recoveries, NoSQL product data recoveries internally, how it happens. There is inbuilt recovery. The server get reboot all of a sudden. How it does the data recovery? There is a differences in terms of recovery in the NoSQL, in the RDBMS. We will see that in the architecture in detail. For now, NoSQL means not only SQL, it is a new database that is not based on the relational database management system principles. It is does not follow the database RDBMS principles. It is opposite to RDBMS almost in terms of data recoveries, in terms of data management, many things in fact. Okay, it is defined for the big data platforms, not for the small. You can use for the small also, but the actual intention of these NoSQL products like Hadoop also NoSQL in fact. Hadoop also NoSQL system. So all NoSQL products are defined and designed for huge data platforms, not for the small. You can use for the small also, it won't reject, but these are all scalable with the huge data. And these are all new SQL, new generation, third generation databases, which mean these products are designed for the latest applications. Like some applications, they don't care about backend; they only care about front end development. They don't have to worry about the backend; they only develop the front end. They can load the data the way they want it. They don't have to define anything in the background. It takes care of automatically everything. That's we have seen just now in the beginning. Data can be in any format. It can have any data, like adding the email also. Example, data can be any format, but if you see this data, every record has different shape when you look at it. So when it is different shape, how it is accepting, because it follows the dynamic schema model. First record has only one field, two fields, three fields, four fields, and five fields. Every record is independent. No dependency between one record to other record, and data can be any format. So this is where the one of the biggest selling point for the NoSQL basically. It is designed for the no new generation applications, because you see any Play Store app, whatever the data you load, it will accept those apps. In fact, they don't restrict you, keep this much of data only, keep in this format only. They won't restrict you at all, because they are implemented on the NoSQL platforms. They accept the data the way you are feeding into it. So all Play Store apps are deployed in the NoSQL only, mostly, most of the product. It does not have any relation. One database, you cannot join two tables here. You have like a table A and table B, or collection A, collection. You cannot join the data and get out of it. There is no joining mechanism in the Mongo. Then how do you actually keep the relation between the data? In relational, you can divide the tables and keep the foreign key relationship, and then connect using the foreign key relation, read the data using the join operations. All that is possible. In the NoSQL, it is not possible. No relations. Record to record itself, there is no relation. Leave about database to database. One database does not have any relation with other database at all. You cannot join them. You cannot join two databases data into one output. In fact, it is not possible. It operates in a different way. That's why it is called non-relational. It does not follow any relation between any databases, any tables here. No relations at all. It runs on the commodity hardware. You don't have to acquire the super class hardware, because you are distributing the data to many machines. You are keeping the minimal load on each server, so you can run the data on the lowest, like cheap hardware, not on the costly hardware. Commodity means a cheap hardware, affordable hardware. You don't have to spend money, lot of money on the server class hardware. You can run on the cheap hardware, because you're distributing the data. You're not hammering one machine with all your operations. You're distributing, so data is minimal on each node. Servers can be cheaper hardware. They run on the cheaper hardware also. Open source is the biggest driving factor, guys. Nowadays, even in the RDBMS, Postgres is growing really well. Why? Because it's open source. People are showing a lot of interest towards open source. NoSQL is also open source. Almost like Enterprise Edition, you get this immediate support. That's a different story. But Community Edition, if your team is expertise, you can manage your Community Edition. You absolutely manage your data in the Community Edition. You don't have to go to the enterprise. Let's take our example. We have 90% of infrastructure on the Community Edition. Only 10% is licensed with Enterprise Edition. So understand, 90% of the data we are operating, which is very huge. In fact, we are a financial system. In fact, so 90% of the data we are running on the open source. You are not paying anything at all. Only 10% of the data we are using enterprise. We are saving a lot of money there. Lot of money. That's where the open source are growing very fast in the market to save the money. Everybody looking for the money saving. Obviously, people are doing the businesses to get the money out of it, not to pay someone, right? So when you're getting the option, people definitely adopt. Schemaless. We have just seen that data is absolutely on, and on the fly it is taking the the field set. It is not rejecting anything. I did not define S number, S name, S address, or phone number, email. If it is RDBMS, you have to define. You have to define the structure, what you have it. You have S number, S name, S address, three fields. You can only load the data within the three fields. If I wanted the fourth field, I need to add that field to the table. Then I can load the fourth field. That's how it is. You have to define the structure, then load the data within that structure. NoSQL is not like that. It is absolutely schemaless. On the fly, it takes the data in any format. The another big point is inbuilt data compression. Data compression is available in the open source also. That's a great thing in the Mongo. If I am loading 1 GB data, it will show you as 100 MB only. 90% it can compress your data by default. If it is RDBMS SQL Server, we'll have a page compression, row compression to save the to compress the data. If it is a Mongo, we have a snappy compression by default, which comes with the Community Edition, Enterprise Edition. It will compress your data like anything. Okay, depends on the data type. If your data is like videos, scan docs, photos, PDFs, that won't compress a lot. But if it is a plain text data, it will compress up to 70 to 90%. Huge level. It will save lot of infrastructure. It is by default comes with the product. You don't have to add it. By default comes with the Mongo itself. The inbuilt data compression within the Mongo. Highly scalable compared to, if you talk about RDBMS, okay, the scalability is when the scalability will be high when data is in limited. When the data grows abnormal, hitting one system for all your data, even read operations also, you cannot go to multiple servers to read and combine the result set and give it to you. It's not possible. Read will go to one node, which is secondary to distribute the workload, but one read will go to one machine only. That read need a huge bulk data, then you are choking the IO, right? If it is a huge data. In the RDBMS, you are not. You are reading the data from parallel physical servers, not one server. That way, you get the highly scalable databases. Scalable, more performance than the RDBMS. NoSQL is way better than the RDBMS in terms of performance if you visit the cluster. We will see that in action anyway. Highly available compared to RDBMS, it is not a single point of failure. 10 TB database will go down if 8 MB of data is lost or corrupted. It will be completely down unless you repair it. So it's not a single point of failure. If it is a sharding and 20% of the data loss, still 80% is operational. Availability will be more, of course. You are going inconsistent if you are doing that, but your available data can do the business. You're not completely going down, which is definitely an advantage. It will give the more availability than the RDBMS by design, by default. Supports the base property instead of asset properties. This I'll cover in the architecture, not now. What is asset properties? Right, we're going to discuss atomicity, consistency, isolation, durability, what exactly they are. What is a base property? Basically available, like eventual consistency something. Okay, we will see this base differences between this and this. In terms of data recovery, how Mongo recovers data if it unexpectedly got shut down, restarted. The in-flight operations which are not written to data file, how it recovers those, that talks about this. We'll talk about the asset properties, base properties in the architecture. To get all these benefits, what we are talking about, we have to run in the cluster, like this kind of cluster. You can run a small one machine, only standalone. You load all your data here, one single machine, only full backups available, which is a full dump. No log backup, no differential in the Mongo, only full for the standalone. If it is the production, you go to the replica set to have a data availability. If data get replicated to three machines, if this goes down, it will pick up the primary role. You will see the data availability, not scalability. Availability comes with the replica set. Replica set. You can run the Mongo in a single node, but you would see one day data loss in the event of data crash. Worst case around, because full backup, which is full dump only available, no differential, nothing. When it comes to replica set, you can take the log backup every 1 hour, daily full dump, every 1 hour log backup, which is off log backup, and you can recover the data up to last 1 hour in a worst case scenario. We can recover up to the point of failure. We will see that. I'm going to damage the data. I'm going to show you how you recover up to the point with the replica set. But worst case, 1 hour data loss with the replica set. Production, RTO, RPO, we know that, right? Recovery point in time, all that. So that can be defined based on the architecture. So if your data is growing more, this you will convert into sharding. This way, you grow the data, the infrastructure will grow, and your performance to grow performance, you have to make it sharded. Like you had a standalone, if it is a become production replica set, from replica set to sharding again, because data is growing more. That's how you grow with the data, to scale with the data, basically. Built for new generation applications. See, why new? Basically, that word why it is they are using new. See, if you talk about 15 years ago, just talk about 15 years ago itself, we were not having any smart devices. No tabs, no smartphones, only QWERTY keypads. QWERTY means a keypad with numbers. You cannot generate the data there. You can only make a call, you can only receive a call. People were not generating the different types of data at that time. 15 years ago, I'm talking about. Okay. So systems are only available to the people who are interactive with applications, not with the devices. So applications are actually loading the data in a given format. The format is already defined in the RDBMS, structured format. Nowadays, everything is dynamic. They wanted everything on the fly. Certain applications absolutely dynamic. Example: system logs, system health logs, application health logs, or cookies information, sessions information. Those information always comes with a big string, small string, different fields, errors are different. So everything is different. RDBMS cannot take such data, health data. You definitely need a MongoDB. We are using MongoDB for all infrastructure health events. We have a Splunk tool which will extract all the logs, load into Mongo. From the Mongo, we generate the reports to show the health of the infrastructure on daily basis. How good, how bad, based on that errors recorded, in fact. Okay. So that way, the MongoDB is getting used. Even they don't have any use case, they're using for the health records in the companies. So you see, most of the companies Mongo is there nowadays. Okay, now again, why no SQL? Let's talk about the challenge. It resolves the challenges faced in storing, managing, analyzing, archiving data. So it deals with a huge bulk amount of data. Like you wanted archival data, old data, historical data. You wanted to keep in the Mongo, live data in the product. So whatever the data you are archiving means purging from the production, loading into Mongo, you are keeping a limited data in the production. Old data, if you want, data is there in the Mongo. So that way also, like they wanted to keep the old data, they cannot keep in the RDBMS. They can push it to the Mongo. Example, I wanted to convert this SQL data into Mongo for any reason. We have only three records. I want to read this data into NoSQL format for JSON Auto. Every product will accept the Mongo data, but you need a tools, third-party tools. Small data, we can do that. If you read this data, data come in the NoSQL format. SQL data read into NoSQL format. I'm keeping it here. Example db dot teacher dot insert many. There is a function to load this kind of data. Now I'm going to run this query inside the Mongo. SQL data converted into Mongo. If I go and read the teacher dot find, you'll find that data. See, SQL data converted into Mongo. So what I'm trying to say here is you can take the data from any source to Mongo because every product in the market supports the JSON format, which Mongo accepts the data. Mongo accepts the data in the form of JSON only. So JSON formats are accepted by every product in the market. So you can push the data from SQL Server to Mongo easily using the third-party tools. They are paid tools, not free tools. In fact, we have done the migrations SQL to Mongo. I'll show you that how that can be done with the minimal data. But we have a huge data. You have to go the licensed version only. Free version cannot do it. Okay. But anyway, conversion of data from NoSQL to Mongo, Mongo to NoSQL is there are tools available. Convert the data on the fly. In fact, on the fly, the tools will do it for you. So Mongo is growing that way also. They want to keep the archival data on the Mongo, which is cheap, and you can keep community edition. No need to pay for it. So this kind of requirements getting the Mongo in the companies, in fact. Social media, any social media, absolutely on the NoSQL only. No concept of RDBMS at all. RDBMS cannot scale first, cannot take the data the way the people are uploading to the system. Someone writes the data, someone uploads the video, someone doing some activity, random. There is no structure for it. So that is not served by the RDBMS at all. Need of continuous availability. So basically, you never see the Instagram, Facebook, Twitter going down. You never ever see that. Why it will not go down? It is also system somewhere. You have lot of systems working for you. If this system goes down, other server is there to pick the primary role to accept the operation. You're not entirely going down. You're going on one server, other server will be there. So one server will be in the remote location. Even these two got down, other one will pick. Entirely this is down, this is available. So that way you don't see the downtime. Servers are available. With a small chunk of data also, it is protected with multiple copies. Of course, you need more servers to have this kind of thing architecture, but they are commodity hardware. You don't have to get the super server class hardware. You invest a lot of money there. You don't have to. That is affordable for any company. Need a flexible data model. The same thing, like dynamic schema model or schemaless. Everything is dynamic. Data can be loaded in any format that RDBMS cannot do. Mongo in the sense NoSQL only can do, right? NoSQL database are great solution to growing scale of databases and falling price of commodity hardware. So this runs on the cheap hardware. Cheap hardware, day by day the prices are falling down. If you talk about 5 years ago, 1 TB used to example 10,000 1 TB. Now it come down to 4,000. 60% of the price, cost is happening on the hardware. If you talk about 10 years ago, even I purchased a pen drive which is of 2 GB for 1000. 2 GB for 1000 in the beginning days. Now for 1000, you get 1 TB pen drive, 2 GB to 1 TB. So see the variation, how the prices are falling down as a technology advancing. So the cheap hardware I'm talking about, like if you go to SSD drives, like solid state drives, they're costly, of course. They're also coming down day by day because the more technology, advanced technology is coming in, and you are getting the other storage types are lesser cost basically. But anyway, down the line you are seeing the hardware cost is coming down. You see the benefit because you can run on the cheap hardware. Cheap hardware is getting less cost day by day, which is good for the Mongo product. So column based stores, key value pairs, document based, these are all product types anyway. It offers capabilities to handle large volume of data using various available features. So it is giving that clustering distributed computing model, and you are able to write the data into multiple systems at a given point, read the data from multiple systems. Even one entire chunk of data is down, still cluster is available, and inbuilt data compressions, schemaless, open source. These are all big points. These are all not given in the RDBMS. So you definitely have to adapt to the NoSQL only to fulfill these use cases in the business. And that's how the Mongo is getting implemented in the market. Benefits of NoSQL again, continuous availability, no single point of failure. Even one of the shard is completely down, still you are not out of business, you are operational. But yes, there is a issue with the whatever the shard is down, you have to make it online. If any connection is dependent on that chunk of data, that will get failed. Multi data center capabilities. What exactly it mean? You can run two sets of here in one data center, one set in a remote data center. Okay, so that if one data center is completely down, you still have your data. It becomes too clumsy, right? So anyway, so I can keep two nodes in one data center, third node in a different data center. If this data center is completely down, you have the 100% data here. That way we can protect the data using the multi data center implementation for replica set. Easy replication for distributed location independent capabilities. Basically replication is so simple. One single command will configure replication. One single command will form a replica, the sharding in fact. Configurations are dead simple in the Mongo. Only the maintenance side you have to have a good understanding on the architecture to troubleshoot the issues. That's where we're going to focus more on the troubleshooting side in the course as well. High performance with the linear horizontal scalability. The machines are distributed. That's why the connections happens horizontally, not vertically, to scale with the data. Flexible schema model, dynamic schema model, easy to implement and grow. Very easy to implement. Data also can grow any amount of data, and open source. These are the big points compared to RDBMS. When you compare with RDBMS, why NoSQL? These are all points we need to consider. And let's compare a bit of it. Let's comparison if in terms of terminology here. Okay, In RDBMS, everything is fixed. You cannot do anything. If you define a table structure, it has to go within that structure only. It is a dynamic schema. You don't have to do anything. Vertically scalable, like in a single machine, you grow, you add more resources, you do everything in a single machine. It is not like that. You add a different physical machines to the group, and data scalability will become more difficult to handle. Big data, when the data grows too big in a single system, it will become tough. You cannot do the proper maintenance of the data, then performance will degrade down the line. AI can handle any big data. You are not loading all your data into one system in different physical machines. Okay, that's why you can easily do the maintenance activities. Mix of open source and proprietary, mostly proprietary, like SQL, Oracle, the top leaders in in the RDBMS, right? They're completely proprietary. The open source is very, very limited, in fact. Okay, Postgres also has open source, but again, you have to go to the third party vendors to get the support. If you go to EDB, enterprise systems database, then you will get the support. You have to pay for it in the Postgres. Basically, it is a licensed product, EDB, in the Postgres. You can no need to go to EDB. You can run your own open source. But if you issue comes, if you cannot resolve, you have to buy the third party support model. For the Postgres open source, I'm saying it. So in the IDBMS also, Postgres growing good because of the open source nature. Mostly standalone. We don't run every server in the availability group or clustered or in the group of what technology, whatever the technology, rack concept and all that. You don't implement on every server, only critical servers, mostly standalone only. Here we run when the data is big, you have to go to the cluster only. There is no other option. Single point of failure. A portion of data is corrupted, your entire database will be down. Here, 20% of data, or a lot of 50% of data, two shards, one shard is down, other shard is still operational. 50% of data is down, other 50% data is operational. No single point of failure. Asset property, base property. So, asset property, base property, I don't conclude for now. We'll see in the architectures. Need for server class hardware, you need a sophisticated, highly scalable hardware. Here you don't need it because you're not putting everything in a single machine. It is very costly compared to in terms of licensing. Even if it is enterprise license, it is average. If you are paying $100 for the licensing part, here also licensing, you pay roughly $20 to $25. It's 75% cheaper than the RDBMS compared to enterprise I'm talking about. So very much cheaper compared to RDBMS license, even if it is a paid versions. So if you talk about NoSQL products in the market, there are many. In fact, you see the Redis server, Memcache, Scalaris, MongoDB, CouchDB, RavenDB, Bigtable, Cassandra, HBase, Hypertable. These are related to Hadoop, HBase and Hypertable. Hypertable, Postgres also supporting nowadays. NoSQL, Hypertable. Infinite Graph, FlogDB, these are all different products, guys. Out of which you would have heard mostly Cassandra and MongoDB and Couch also as cache database. Redis cache also. This is also slowly coming into market because cache databases. Mostly Mongo, first Hadoop, then Mongo, then Cassandra, then all other. That's how the hierarchy if you talk about implementation wise. Okay, just a minute. What is a big data? If someone asks you, what is the definition of big data? NoSQL supports the big data. Okay, how do you define the big data? Big data, in fact, big data involves at any given point millions of users across the globe. They are hitting the system, still they get the response, and they are running millions and billions of queries. Still they are scalable, and like a lot of data, wide variety of activities happening. Still systems are available, no downtime, no performance issues, because one request is served by hundreds of systems in the background. No single system is not affected. That's why you get the quick response for any number of sessions are hitting. No exhaustion of the resources because it's not on a single machine. That's how you scale on the big data. Big data deals with the volume, huge volume of data, wide variety of data, structured, semi-structured, unstructured, anything. Data can come in any format. Velocity. The speed. So huge data, variety of data, different type of data with the best performance model. So the three V's are characteristics of any big data platform: volume, velocity, and variety. These are all obeyed by the big data platforms to give a solution for a huge data models. If it is RDBMS, what DBMS means vertical scalable. If the data is growing, increase the CPU, increase the RAM, increase the disk space, good enough. But as you increase the more CPUs, high cost you have to pay for it. And downtime is, if your downtime is definitely will be there. If even it is clustered also, you have to fail or fail back. That is a small interrupted downtime. But anyway, downtime definitely needed. Any system, even in the Mongo also downtime is needed. This is a point common everywhere. Of course, a limited downtime, like if you have replica set fail over failing back during the transition phase, there is downtime. Threshold and limitations: you cannot run any amount of data in a single system beyond certain manageable storage. You cannot scale with. Single point of failure: some portion of data is corrupted, you lose your data. That's there. If it is no SQL, you add more machines, you scale well automatically, you don't have to worry about. Disadvantage: compared to disadvantage, advantages are more. Less cost, you can implement the hardware with the less cost. Lesser cost hardware is becoming less cost day by day. In fact, no downtime, no limitation. Downtime will be there completely, you cannot say no downtime. When we do the activities, there will be limited downtime. No limitation of amount of data. Whatever the amount of data you keep it, there is no limitation. No single point of failure. If one of the shard is entirely down, still other shards are operational. Can be scaled down with any amount of data, because they are running on multiple systems parallelly, not in a single machine. Okay. Then come to the this point, I'll cover in the architecture only, guys. What is atomicity? What is consistency? How does inbuilt recovery happens? We will do the comparison in detail with the architecture. I'll draw the diagram. I will show how the recovery happens in the background. So then I'll conclude that point, because if I discuss now, it will be above your head. You don't understand. I don't want to confuse you in the first day, first class itself. Let's understand the basics, then we understand the differences on this point especially. Now, MongoDB used to call it as Tengen. Old name to the MongoDB called Tengen. Uh, it is started, in fact, 1998, right? But officially it came to the nine, in fact. Let me quickly show you MongoDB versions and end of life. I just want to show that when MongoDB got renamed to MongoDB 3.0, we want to see up to from 1.0. Just what I want to show this just for your informational purpose. All right, you see that 1.0, it is introduced into the 9. This is where Tengen renamed to MongoDB in 2010 to the 9 10 31st January, and this one too. So in 2009, but this product introduced in 1998 itself. Okay, before that, the same company name used to be called as Tengen, not MongoDB. Tengen itself renamed to MongoDB from 2009 onwards. MongoDB incorporation, in fact. So this is history. So what are the takeaway points from this discussion is the differences between the RDBMS, NoSQL. First is open source. Biggest selling point is open source. Next biggest selling point is schema-less, dynamic schema model, inbuilt data compression, more available, more scalable, right? More scalable, and no single point of failure, no single point of failure, inbuilt data compression. So open source, these are all major considerable points we have to discuss about. What is the major advantages over RDBMS? If you talk about, I kept this in the agenda. What is NoSQL first? Right? NoSQL is another technology just like RDBMS, but it does not follow the RDBMS principle. In fact, Why NoSQL is required? Because NoSQL only can serve the purpose of unstructured, semi-structured data, not RDBMS. RDBMS definitely needed. And scalability wise, availability wise, data compression, cheap hardware. So many points we can come to the discussion basically compared to RDBMS. Why NoSQL is getting adopted in the market. These are all points. We can do all operations what RDBMS can do, like insert, update, deletes on the fly. You can modify the data on the backend technology side. You can do all operations. Why entirely MongoDB cannot take over on the RDBMS? Basically, if it is giving this kind of benefits, you can run all RDBMS products in the NoSQL, right? Yes, there are certain features not NoSQL cannot fulfill, basically. Okay, what are those? We will see in the product in the discussions anyway. Okay, like if you want, NoSQL can do this kind of scalability, availability, and all that, but recoveries are very weak in the Mongo, not like RDBMS. Recovery wise, you cannot recover on the same system. You have to go to different system. It has a very bad recovery. Recovery is there, but you have to go, a lengthy way of recovery. We'll see that. So there are certain things which you cannot run certain critical applications on the Mongo because of the features not so great compared to RDBMS. But whatever the features we discussed, they are great compared to RDBMS. So you need to see the balance where getting more. So you MongoDB is giving more benefits or RDBMS is giving more benefits. You look at that perspective, and it's not your job anyway. Your client will pick the technology. You only support it. Right. Along with this, just for the introduction's sake, I'm I design this course into 10 modules, in fact. Okay, 10 modules. Next two discussions will happen on the entire Unix basics. Next three classes, I'll spend, you don't have to know anything about the Unix. I'm going to cover next three classes, absolutely all basics. Those basics enough to manage the product. Any product, not only on the Mongo. You can run Postgres, you can do any product management if you know all those basics, what I'm going to discuss in next three classes. First, I know that some people are already working on Unix flavor, but most of the people I know that not working on the Unix flavor. So I wanted to bring everybody to the same page, then start the product. First, we'll go through the architectures. I'll do the basic installation of Mongo. Then architectures plays very bigger role, guys. If you know architecture, then only you understand the issues what I'm going to discuss in the future. So it has a very high weightage when it comes to the troubleshooting. If you understand the architecture, you can understand every issue that I'm going to discuss. So it has a very good weightage. So we're going to spend on the architecture. Then CRUD operations. You have to do a deployment. Have you review a deployment? First, I'll cover the development stuff in these two modules. 50% of the development. You don't have to scare. Any LKG guy can follow me. That simplicity I'll make that you easily follow it. How you can write your own script. It is so simple, guys. You feel that it is absolutely simple because I'm going to discuss in that way. Okay. And performance tuning is a big topic for us, and this is a major big module for us. This is where most of the administrative actions will be discussed. Backup and security, replication, sharding, monitoring tools, developer tools, and Atlas. Everything will be discussed in the last module. Okay. And automations, how you automate the backups, how you clean up the backups using the shell scripts, how you recycle the Mongo using the shell scripts. So shell script automation also we have a discussion. In fact. Okay. So you don't have to know anything about the Mongo. I'm responsible to take you through right from the scratch to L3 level activities. Everything that you do as a DBA L3 level, I'm going to discuss in the classes anyway. Only thing I would require from you is be regular to the class to take away most of the things what I discuss in the class. Be regular to the class. That's important. So, any questions from anyone before I stop the video? Just stay back. Anyone have any question? Fine. I'm stopping the record.